Hi everyone, welcome to Convex, where we are celebrating experiment-driven marketing. I am Pallav and I'm an optimization consultant here at VWO. Do you want to fix leaks in your conversion funnel? Then do check out VWO. Right? I am really excited to have Iqbal Ali here with us today. He is head of optimization at Trainline. So Trainline is a leading platform to book train tickets in Europe, and they also serve in 45 different countries in Europe and across the world. So I'm really excited to have you here with us, Iqbal. So before Iqbal, you begin your presentation, I just want to inform all the audience here with us that they can go to the official Convex's LinkedIn group and they can ask all of your questions there itself regarding the presentation. So with that, Iqbal, I think we are good to go, and the stage is all yours.
Hi everybody. I've titled my my talk "Science of Testing at Trainline." I think it'll become apparent why. So my name's Iqbal. I'm the head of optimization, as Pallav has explained. A little bit about me. I'm the head of optimization at Trainline. I've been experimenting for about 5 years now. I've got a background in UX and front-end development, and I'm also a bit of a process nut, which will become apparent. So about the Trainline. So we sell train tickets worldwide. There's about over 45 countries and the rest of the world. Just to give you a sense of the traffic that we have. So we've got 80 million visits per month. This will give you a sense of the conversion rate. We sell more than 204 tickets a minute. So it's a lot of tickets that we're selling. And also our team. Our team is kind of big, 600 plus people, and we've got 300 plus people in the travel, as travel tech that we call them, specialists and developers as well. So there's a big team over here. So a little bit about this talk. Hopefully I'll be giving you an insight into our experimentation process, and I'll be explaining why and how we try and maintain a scientific approach to experimentation. Just kind of like why it's so important. So what's our goal? Well, our goal is to develop a process that can be rolled out across the entire organization, and we want to develop a test and learn culture. So we've got, like I said before, there's a lot of people at the Trainline, a lot of teams, each with different goals and kind of areas of responsibility. And so our goal is to roll out a process that kind of fits everybody, and also obviously to increase conversion. So I think it's important to note that what our expectation is going into our any experiment is that we expect a win rate of about 20 to 30%. Inversely, that means that 70 to 80% of the time, we expect our experiments to not win. So it's important with those experiments that are not winning that we're still learning something from those experiments. And also, in terms of looking at the win rate, 20 to 30%, I think it's important to note that test velocity is important. So we need to be running as many experiments as we can in order to gain as much conversion uplift as we can. So what are our challenges? Well, we've got a lot of people, so we want to try and develop a process that is robust, yet flexible enough to deal with all of the different teams and their responsibilities. I think even though we've got a lot of people, I think it's still important to maximize the efficiency at which we use them, efficiency of resources. It's not necessarily just efficiency of resources of the personnel, but also in terms of traffic. And we want to remove as much subjectivity as possible from the process. So we want to be objective in the way that we prioritize and go about experimentation. And as I mentioned before, maximize the use of traffic. We've got a lot of traffic. We want to try and utilize as much of that traffic as possible in experiments. And I think this is a really key point. We want to maximize learnings for effective prioritization. So this is what gives us this kind of like a process that helps us learn and develop new hypotheses. So I guess the key word here is scientific. It's objective. We want a process that's repeatable, that's reusable. We want a process that can help us achieve some validated learnings. And this is an overview of our process. So we start with the hypothesis, we prioritize, deliver, and deliver, by deliver mean design, develop, launch the experiment. And then we have the analyzing phase where we just analyze the experiment. And hopefully from that analysis, we get some learnings to then feed into creating new hypotheses and better prioritize the hypotheses. So then that loop back is important. And each time we do that loop, we're hopefully learning something new and we're hopefully getting better. I've highlighted 2 of these steps in red. That's because these are the areas that I'll be talking about today. So hypotheses, and a little bit about them, and specifically how we write them. We have a very specific way that we write our hypotheses. But why are hypotheses so important? Well, what it helps us do is a good hypothesis will keep the focus on why we're running an experiment. It's important to note with every experiment that we run, exactly what are we expecting to learn from it, and why are we running this experiment exactly in the shape and form that we are. A good experiment as well will help us determine the metrics we need to track. I'm a firm believer in that an experiment is only as good as the metrics that you're tracking. So then it helps you get some deeper insight into user behavior, even if the experiment isn't a win. It helps also focus our design and development. So by having a well-structured hypothesis, it just kind of helps focus designers into the reasons why we're running an experiment, and then it helps them develop the design in that specific fashion. And also from a development perspective, it helps for everybody to know what we're building, because as well we'll be able to build metrics, and everybody will be able to input into the metrics we want to track. And a good hypothesis, it determines what we'll be learning ultimately, because based on your experiment design, which is going to be based on the hypothesis, it kind of comes back to this, what have we learned from an experiment? If a hypothesis is validated or not validated, we'll have learned something from that process. So here's a template of how we write our hypothesis. So it's a very simple template. We just say changing or adding X will describe it, and then we describe the impact, and then we have what we call the justification. So there's 2 parts here. There's the first part here, which is changing and adding will, and then we describe the impact. And then there's a second part, which is the justification. And I'll be going into both of these parts in a little bit more detail, starting with the first part, which is where we talk about variables, basically. So our site is just full to the brim of variables. I think every site is full to the brim of variables. And what I mean by variables is that it's stuff like clicks to a button, views of a particular ticket type in our instance, and also anything to do with page views and stuff like that. But variables are not necessarily metrics. They could be, but they could also be stuff like text on our site, button color, iconography. And then we've got the other variable, the other important variable on the other side, which is that dollar symbol, and that's our conversion rate. So what we're trying to prove with a hypothesis is that we're trying to say that we've got these two variables. So we isolate these two variables. So we've got a predictor and a dependent. So when we isolate a predictor variable, what we're doing is we're picking something like some text or something like that on our site. And what we're saying is that if we make a change to this variable, then we predict that it will impact conversion, which is our dependent variable. And we're predicting that that impact will be positive. So that, in a nutshell, kind of encapsulates the first part of the hypothesis. And and what we're trying to seek is to prove that changing one variable affects another. That's ultimately what our hypothesis is. And by proving causality, we've learned something. We've learned, that something is a conversion lever, or that something works better than something else. It's also important to note that naming our variables and explicitly naming our variables like this means that we know what metrics are important, so it helps us know what to track for a specific experiment. So here's another example. So we've got here, we've made a change to two predictor variables. So maybe text change and maybe something else on the page. And what we still have is an impact to a dependent variable, but this time we can't actually isolate what actually caused the impact. What we know is that both changes combined have caused the impact. Now, there's nothing really wrong with this experiment design, and we might purposefully design an experiment this way, but it's good to note what our expectations are with what we learn at the end. So here's our thing again. So changing or adding X will describe the impact. So we've broken it down into a predictor and a dependent variable. So on to the second part, justification. And the justification is, you can see, we call it the how and the why. It's kind of like looking at the hypothesis and saying, what makes us think that this relationship between these two variables exists, and why it is in the direction that we think that it exists in. So why do we think that making such a change will impact our conversion rate in a specific way? And it all comes down to, with justification, with optimization themes. So with over testing and over looking at researching other places that test, there's some common themes that we have. Like, we call them optimization themes that are known to move the lever in terms of conversion. So there's stuff like relevance, clarity, confidence, reducing distraction and friction, and adding some urgency and scarcity to the pages. So all of those things have been seen to move conversion. They're kind of like conversion levers. So we try to relate justification with one of these themes. So, and what this justification ultimately does, it helps us understand why this hypothesis exists in the first place, and it helps us weed out weak hypotheses. So by writing a justification, it actually really helps to validate, like, do we really think that these two variables are related? You can easily weed out weak hypotheses, and you can easily identify some of the stronger hypotheses. So let me look at an example here. So this is our search results page. This is the old search results page. So that page no longer looks like this. And in this instance, we've identified we had some qual insights that identified that wording direct is a little bit confusing for users. So that is that is some feedback that we've received. And our hypothesis, or a variation that we want to test, is we want to change that wording from direct to say 0 changes, because we think this is clearer to users. So when we write a hypothesis, we write it like this on the search results page, saying 0 changes instead of direct. So this is us declaring the predictor variable will increase conversion. So that is our dependent variable. And we say that this will improve clarity and confidence. So this is our justification, and we're tying it back to those optimization themes. We could also add here that this is based on qual insight, but what we tend to do is to try to keep the hypothesis statement as simple as and compact as possible, and move any other additional information into a separate section called background. So we add in sort of, what is the specific feedback that led us to this hypothesis, etc. So yeah, again, this is one, the variables that we're declaring, and two, the justification. So what this helps us do then is when we develop a hypothesis and we're looking at prioritization, it helps us with the prioritization. And this leads us quite nicely to the next section, which is prioritization. So and it's important to know what our goals with prioritization. Well, our goals is to maximize velocity, and that means we want to maximize the experiment velocity in terms of launches, experiment launches, and experiment conclusions. So we want to have as many experiments live as possible at any given point, and we want to launch as many experiments as possible, and we want to conclude these experiments as quickly as we can. So another point we want to do is we want to make efficient use of resources. So we want our prioritization to help us be more efficient with that use of resources. And we're hoping that our prioritization will keep us objective, will keep us from being too subjective in the way that we prioritize certain experiments over others. And that leads us to prioritization matrices. So this is the system of ranking of ideas, or ranking something by using a set of criteria which you score with. And what the criteria is could be different. There's lots of different types of prioritization matrices. It's basically dependent on what is important to your specific goal and your team, and then based on that you can come up with some set criteria, and then you can score experiments based on those criteria. So what we use is is something called Pi. That's something developed by the Wider Funnel, I believe, and we use a slightly modified version of Pi. And also, it's that this version of Pi is modified between different teams. I'll go into more about what Pi actually stands for and what it means. But for now, it's important to note that we've got these the P, the I, the E. These are criteria, and we've got our experiments. And then we score these experiments. We get a total score, and then we rank them in terms of what is the highest score, what has the lowest score, and that will help us prioritize the tests that have got the biggest impact in terms of ROI, in terms of the criteria that we're wanting to score against. So what is Pi? Well, P stands for potential, I for importance, and E for ease. So going backwards from ease, ease is the ease of development and implementation. So it's the effort that it takes to develop an experiment and put it out into the world. 10 is classed as the easiest thing we can do, so maybe some kind of like copy change or something. And 1 is maybe the hardest, like changing an entire flow or conversion funnel. And what ease helps us do is it helps us with efficiency of resources. So efficiency in terms of development resources, and also like efficiency in legal resources. So if there's something that needs a lot of legal input, then that's something we also count as kind of like the ease of getting a test out. Next up is importance. So importance is the volume of traffic exposed to your experiment. So I think that's it's an important thing to note, that it's the volume of traffic exposed to the experiment, because even though we might be running an experiment on a specific page, maybe not all traffic to that page is going to be exposed to that experiment. So it might be only 50% of that traffic exposed to the experiment. And what we do is we've gone away and we've ranked all of our most trafficked areas of our site, and we rank 10. We score 10 with the page that has got the highest amount of traffic, and everything else is scored relative to that. So if there's a page that's got 50% less traffic than our 10, then that gets a score of 5, and so on. And what this helps us do, what importance helps us do, is it helps us prioritize experiments which not only conclude fast, but will give us the bigger impact, because we've got a lot of traffic, and so by focusing our efforts on the places where we've got the most amount of traffic, we should hopefully reach conclusion to our experiments sooner, and also we should be able to see some bigger impacts. So on to potential. So so far it's been very similar to wider funnels pie scoring methodology, and here we start to diverge a little bit in terms of we do things in a slightly different way. So here we've got potential, which we break potential into 2 parts. The first part of potential is very similar to wider funnels process, where we have where we've ranked all our pages in terms of the highest drop-off. So for example, if you've got a page from one page to another, we've got a funnel, we go from step 1 to step 2, and the drop-off is about 80%, then maybe we want to prioritize that page in head of a page that has got only a drop-off of like 5%, for example. So like I said, we've gone over, ranked all areas of our site with what is the biggest drop-off area, and everything else is scored relative to that, similarly as with importance. And what this does is it helps us focus on the worst performing areas of our site and app. So again, it's going to help us in conjunction with importance. It helps us focus in the right places, a lot of traffic and badly performing areas of our site. So part 2 of potential, what we also do is we score a potential for this specific experiment to succeed. So the reason why we have this point 2 is because we could be doing a lot of tests on one single page, and what we needed is something to drill down and to isolate based on what the process went through, the hypotheses. We've hopefully got some strong hypotheses in our backlog now. So then we want to be able to look at these hypotheses and be able to score favorably tests that we think have got a higher potential to succeed. So what we do by default is that we say, because let me start by saying, this has a tendency to become very subjective. We've optimized this part of our process quite a bit. Previously, there was a lot of discussion around this part of the process, but since we've optimized our process, we've come to this definition of this kind of way of working out the second part of potential, which has reduced that won at the time of discussion, and also made us a lot more objective. So what we do is we basically say every experiment that has made it this far, that has gone past the hypothesis validation phase, we've written our hypothesis, we've validated it because we can weed out all the weak hypotheses using justification. So we can see that if an experiment has got this far, it has a 50-50% chance of winning. And then what we do is we add or subtract based on evidence. So if we've got some qual evidence, some insight from user feedback, for example, or if we've got some past experience with previous experiments, or something in the analysis that kind of suggests that, you know, in the data analysis that kind of suggests that this is going to be this has a high potential of winning. And what this does is it helps us prioritize experiments objectively, and more importantly, it helps us that feedback loop I was talking about before. It helps us learn. So every time we're going through that feedback loop, we've got a test that's been analyzed, we've got a win, and then now with the new bunch of hypotheses that we've got, when we're scoring these hypotheses and we're prioritizing them, we've got more evidence to suggest whether or not, or to better kind of tweak our ability to predict whether an experiment is going to be a win or not. So here's an example. We've got an example experiment here. 40% of traffic to a specific page is eligible for this experiment. So imagine this, we've got this page, 40% of traffic that land on this page is eligible for this experiment. That means maybe a specific segment. So in our case, maybe, I don't know, a single search instead of return search, or something else that basically means that only 40% of traffic to a specific page is exposed to the test conditions. And where there is no previous history or evidence. So this is a brand new hypothesis. We don't have anything to back up or any qual or quant insight to kind of predict where this could go, and where the experiment is easiest to implement. So let's say it's some kind of copy change. So this is an example process that we go through with a PyScore. So in this example, so we start with the P. That's our middle line where there's no previous history or evidence. So imagining this page, we're focusing up for this page, this specific experiment is maybe focused on the page with the worst drop-off, highest drop-off. So that's the page with our score of 10 for the first part of potential. So since we've got no previous history or evidence for this test, it has a 50-50% chance of succeeding. So therefore, we give it a score of 5. And in terms of importance, I said 40% of the traffic is eligible, are going to be exposed to test conditions. And for this example page, let's say the I score is a 6.2. So what we do is we take 40% of that 6.2, and that gives us a score for I. And then for E's, 10. It's some copy change. So this is what we do. We just kind of sum them all up, and then we get a PyScore at the end. It's important to note that, like I said at the beginning, we're a big team. There's lots of us, and not every team uses the same criteria in the same way. And some teams also have different criteria that they mark against. The pi scoring that I showed is just a classical example. It's a starting point. From that point onwards, we can, it's kind of, it's quite flexible. The point is that we have a certain criteria that we know is important to that team's goals. and what it is that they're wanting to test. So here's our overview again. So hypotheses, prioritize, deliver, analyze, and then we've got that loop. So like I mentioned before, hopefully each time we're doing that loop, we're learning something new. It feeds into more hypotheses, and then ultimately it helps us with this win rate of 20 to 30%. So hopefully it keeps gets our win rate in the high region of that, and hopefully means that from each experiment that we're running, the whole teams are learning something new, something interesting, something different, and all of that feeds into new hypotheses, and we have a backlog of experiment ideas that's really healthy. And so what we hope this will give, and what we find that it gives us, is a robust yet flexible process. This kind of process helps us maximize efficiency of resources. It's helped us be as objective as possible in the scoring by saying that by default everything's got 50-50 unless there's actually objective some data to suggest whether a test is could be a higher potential to win or a low potential to win. And it helps us maximize the use of traffic as well. And ultimately, like I said, the main goal of this is to maximize learnings for effective prioritization. So if the process is working, then each time we're doing that loop, we're learning something new, and that kind of process is getting better. Another important point is, and I think I touched on it a little bit earlier with the PI scoring, we optimize our process. So by knowing what it is that we're wanting to achieve with our process, we're able to put some success metrics against it, and then what that helps us do ultimately, I think, is to optimize the process to get better at it, and hopefully that leads to more wins and more interesting experiments. Thank you.
Thanks a lot, Iqbal, for a wonderful presentation. I absolutely loved your minimalistic slides, and it was really simple to understand all the things which you said in the presentation.
Thank you very much.
Great. So we would be starting up with questions. I do have a few questions to ask you, right? So I was wondering that in the entire presentation you mentioned about the process and optimizing that process. So I was wondering if there are any other way in which you have optimized this process beyond what you have already shared with us.
Yeah. So in terms of the there's some other steps with the delivery and the analysis. So we've also been we've rolled out, or with the analysis section, we used to use frequentist statistics to determine test wins. We've now moved to Bayesian analysis, and we've implemented a process or a way of working with Bayes called expected loss. Which is, I think, related to, or your data science engineer over at VWO, Chris Stucchio, wrote a paper about, which was quite interesting. And that's been really helpful in terms of trying to get an easier way of people to understand experiment wins, and an easier, more business-centric way of determining test wins, rather than this scientific kind of frequentist p-values. And also there's in terms of delivery as well, there's like just in terms of development processes, just optimizing those, tweaking those to get better in that section as well.
Mm-hmm. Yep. So there was a slide which said that this process would not be same for every team, right? So I was wondering if the process which you are using at Trainline, how has that changed people's understanding of user behavior or experimentation in general?
I think it's made people more aware that that not everything is going to be a win. That I think everybody goes in with an expectation that, oh, we've got a win rate of 20 to 30%. Yeah, we can get better than that. So this, and looking at specific sort of experiments and saying, this is definitely a win. There's not a shadow of a doubt that this is going to be a loss. But in actual fact, once you launch an experiment, there's so many variables and conditions out there that you really don't know or cannot predict the outcome of an experiment. So I guess that's another thing that we've learned, and others who've done the process have learned. And also, it's helped us kind of fine tune our sort of the way that users use a site, on our understanding of how users use a site. So what their behaviors are and stuff like that, and how that maybe differs from what they say in terms of the user feedback that they present.
Mm-hmm. So you talked about the complexity of concluding a campaign, right? So I had a lot of occasions in which I created multiple goals or conversion points, which you can call as metrics. And what happens was that I created 3 metrics, and sometimes 2 metrics gives positive results in favor of our hypothesis, and 1 metric actually gives negative result in opposition of our hypothesis, right? Then how can you how do you have a process regarding that? How do you conclude a campaign like for this example?
So in that example, what we'd look at is, say we've got a number of metrics, and some metrics are positive, some metrics are negative. Mm-hmm. Ultimately, there'll be a success or critical metric that we'd be interested in. And if that critical metric is met, then we base our decision whether or not to roll an experiment into production. Like, for example, if it ultimately is a win, then yes, we could roll it. But maybe, like you're mentioning, our hypothesis is not quite correct in terms of we made this change, but it's not because we increased clicks to something that increased conversion, but maybe because we decreased clicks to something and then that increased conversion. So ultimately, the next step would, in our view, and the way we would do it, is that it's ultimately a win. We'd roll it out. We'd come up with new hypotheses in terms of this is a valuable learning that we've had, and generate a brand new set of hypotheses in which to test and to iterate on that experiment. If the experiment is ultimately a loss, then again we do that iteration, and then we'd iterate on that feature or on that thing just to see what it was that happened there that caused such an impact or such a behavioral change.
Mm-hmm. So talking about hypothesis in general, do you create a hypothesis device specific? For example, when you took the example of the experiment which you ran in which you changed the copy. So let's say that campaign actually wins for desktop and loses for mobile device, right? So then how do you conclude it? Do you roll out across all the devices, or do you take a decision on the basis of data itself?
Good question. So it depends on the outcome and the value of the impact on both the desktop and the mobile. Sometimes there have been cases where we have separate applications for mobile and desktop. So the impact is never as, we don't have to deal with things in that kind of same sort of scope. But for example, with desktop tablet, for example, that maybe if tablet is a loss and desktop is a win, it ultimately depends on overall what the impact is. So there'd be some deeper analysis that goes into that in terms of what is the overall impact. And maybe we'd only roll it out to desktop only, or maybe only rolling out to tablet only. But we'd have to look at the cost of which, starting to diverge, the two platforms perhaps. But ultimately, maybe as well, what we would do is we would probably feed into more hypotheses and seeing if we can have a solution that actually works for both. So what we tend to look at is we have the happy path where every segment is positive, and then we can roll out a test. And then we have a slightly less happy path where we have certain segments that are lower, and based on the importance of those segments, we might decide to loop back, do another experiment before we can roll something out as a feature. So that it's that loop basically that is all important. The analyzing and creating new hypotheses based on that, and seeing if we can optimize what we've already optimized.
Mm-hmm. Okay. You mentioned pi in your slides, right? So what do you do when the pi score is exactly the same for two different hypotheses? Then how do you prioritize them?
I guess it comes down to whichever one is slightly, there'll be one that's maybe slightly less friction to get out the door, maybe one that doesn't need so much design work, maybe something that can be just done by developers. You know, there'd be certain instances that even if you got two that scored exactly the same, there might be some differences in them, or there might be some kind of business incentive to go with one or the other. So it'll be the prioritization of the pi scoring. We don't stick rigidly to the order in which they've been ranked. It's just kind of indicative, so we can see like these tests are our biggest ROI, going from highest to lowest. Then there'll be stuff that the business wants to roll out, some things that may be strategic, that maybe want to roll out in order to enable other things to happen. So there'll be reasons why we don't obey the ranking, but at least we'd have some visibility in terms of why we're doing certain things, and visibility that certain test is actually has got a higher ROI. So there'd be certain reasons, specific reasons why we might not decide to go with one, or we might decide to go with one or the other if two are scored the same.
Mm-hmm. So I believe that it would boil down to how easier it is for your team to develop a campaign. Do you actually have a dedicated team for testing?
So we used to have a dedicated team for testing, but these days the goal is just to have all the teams testing. So testing process is baked into every single team now. So it's kind of like we want to have a test and learn culture across the company, rather than having teams in a silo doing their experimentation.
Mm-hmm. Great. So I think this is one of my favorite questions which I wanted to ask you. So we have been facing a lot of challenges while running experimentation. So I would want to understand from you, what is your biggest challenge while running an experimentation program on a company like Trainline?
So I think apart from the operational processes, so like getting people on board with testing, the rolling out a testing culture across the company. Aside from that, I think the biggest sort of challenge has been sort of data integrity of experiments. So making sure that every experiment that we run has got a high data integrity. So because there's a number. So we have a kind of like a score to say how many tests have we launched, do we need to relaunch, or have just been invalid. So we want to try and keep that rate as low as possible. And it's a constant. That's a real challenge in trying to make sure there's so many teams testing, how do we maintain that data integrity so that when you're analyzing an experiment, it is valid data that you're looking at.
Mm-hmm. Okay. Just a fun question. Are you a reader, and how many books are you reading right now, and what are you currently reading?
So currently, I'm reading on Audible, if Audible counts. So To Sell is Human by Daniel Pink. That's a really good book. It's kind of like going through the kind of making the point that every one of us is a salesperson, and what the techniques and how selling has changed over the years and stuff. And also Naked Statistics, which I'll be honest, I've been reading for a long time, but it's a really good book, Charles Whelan, and it kind of like it's really it's actually an enjoyable read. Wouldn't think so based on the title. It's going to be about statistics, but he actually makes it really interesting. So that's also another book that I'm reading.
Mm-hmm. Those are great books for sure. I have also tried reading Daniel Pink. So yeah, I think thanks for answering all of our questions. So that was a wonderful presentation. Just one last question, which we would want you to let us know, how can audience connect you and reach out to you?
So LinkedIn is probably best. You can search for me, Iqbal Hussain Ali, LinkedIn. Twitter also, Iqbal H Ali, Twitter. So, but yeah, just those two places.
Great. Thanks a lot, Iqbal. I think that was a wonderful presentation, and that's about it for our questions.
Thank you.